My name is Roy Rapoport. I work at Netflix. I'm here to talk a little about how we think about metrics at Netflix. And because we ended up having some extra time at the end of this, I'm also going to talk a little about our next generation event management system. A little bit about me. Most of this is not all that interesting. Bless you. I've been at Netflix for about 1,195 days. And for the first 2 years I was at Netflix, I was actually part of the IT side of the house working on our production systems in the data center before we moved to the cloud. So I got to see Netflix's migration to the cloud sort of from the other side of the fence. I want to start this conversation with a little bit of metrics humor, which is kind of embarrassing. So I actually started telling this joke about 15 months ago or so, right after the end of Velocity 2011. I was at a presentation where somebody said, you know, you've got to collect all the metrics you possibly can because you don't know what will probably, you know, prove useful. So I've got this graph. It's a metric that we've been collecting for a while now. In fact, you can see, if you can read, that it starts right after Velocity 2011. This is May 18th, 2011, and it goes all the way to this last Sunday at about 5:45, but that's UTC. And you can see that the number here is pretty jagged. It's kind of interesting. Not exactly sure what to make of it. And then I can add the little scale, and you can see this goes from 48.751 at the bottom to 51.922 at the top. By the way, is the purple laser visible from the back of the room? Because I can use red. I got some thumbs up. Excellent. So, there you go. This is why talking about actionable and relevant metrics is interesting, because otherwise what you end up with is a system that's full of graphs about how many of your instances have an even IP address, or something else that's similarly useless but probably not even intentional. So before talking about what metrics mean to us, I want to talk a little about the context for metrics at Netflix. We'll start with technology. In our environment, we are basically a service-oriented architecture. In our migration from the data center to the cloud, we re-architected all of our services to move away from things like Java serialized objects to just REST calls. And while we're mostly Java, because we use REST, anybody can come and play. So whether you use Java or Python or Ruby or any other language that can do REST reasonably well, you'll do well in our environment. And because of that, we also have a relatively simple architecture. So there you go. Now you know how to create a streaming service. And actually, I have to admit, this is an outdated graph. I got this from about 3 months ago. We actually had a press release talking about this. So this morning, because I wanted to make sure I had the most fresh information, I actually grabbed the latest version of our architecture diagram. And there you go. As you can see, we've made some changes. So the other part of this that informs how we think about metrics is our culture. I don't know how many people here have heard about the Netflix culture. We pride ourselves on this idea of freedom and responsibility. So those of you who have seen, for example, our cloud orchestration system, Asgard, might have seen that there's no authentication or authorization layer built into it. That means that if you're working at Netflix, whether you're a developer or somebody in finance or somebody in facilities or a receptionist, you can go into our system and launch 1,000 instances in the cloud. If you happen to do some really good things with those instances, obviously you might get a slight change in career. But really the focus here is giving the developers all the tools they want and then staying out of their way. The other part of this that you have to be aware of is when we moved to the cloud from the data center, we also eliminated our NOC. So we have no centralized ops group that's going to look at your graphs. There's no centralized ops group to which you can give a run book that will fix the minor stupid problems in your app because you're too busy to fix it. I own an application in the Netflix cloud called Security Monkey, and I am responsible for developing it. I'm responsible for the testing of it. I deploy it, and at 2 o'clock in the morning, if it goes wrong, hopefully I've put in the alerts in place that will inform me that it's gone wrong, because there's nobody sitting up at 2 o'clock in the morning somewhere waiting for these problems to inform me. So fundamentally, the issue at Netflix is that our whole goal is to get out of the way of the developers. We've created a bunch of systems, and what I'm going to talk about in a moment is part of them, that helps the developers do what they do, but we try to exercise no control, no authority over what developers end up actually doing within our environment. And I'll talk about a few great examples of that in a moment. So metrics, what are they good for? Let's talk a little for a second about the sort of metric lifecycle. This is pretty typical. You start with sending metrics into your system. Typically, you end up looking at those metrics. Hopefully, you have fewer monitors on your desk. And then, obviously, sometime around 2 o'clock in the morning, you also end up using those metrics to actually alert somebody that there's a problem, if you ever have problems in your system. Does anybody here, by the way, not have any operational issues? Because that would be great. So, in order to do that, we needed to build systems that were hugely flexible. This basically meant that our whole goal here was to make it so they could do anything that our developers wanted to do starting on day one. They also needed to be hugely scalable. I joined Netflix back in '09 when we were adding systems by the dozens over a week. These days, we add instances by the hundreds over a day. So the scalability is especially critical. The other side of that is that our developers, because they can push whatever metrics they want into our system, occasionally do things like, hey, let's send 80,000 metrics into our system from each one of my instances, which creates interesting scaling opportunities. The whole goal, though, is to have the system run and allow the developers to do what they want without having to actually ask for anything from development or from a provisioning group. So let's talk a little about actually sending metrics into the system. I've actually got a code sample here. This is the Python metric library that I wrote. There's a Java library that was written before me. There's also a Perl library. And if somebody wanted to, they could probably pretty easily create a bash library to do that. That would be impressive and probably kind of stupid. So you just import the library, you create an object, and this self.nm.nf counter just increments a counter named API. And you can see here pretty easily that we have another counter that is application underscore whatever the application is, and that counter will be increased as well. That's basically as simple as it gets. There are other kinds of metrics you can use, gauges, absolutes, derived, things like that. Those names, by the way, might be familiar to those of you who've used RRD. This system was originally built on RRD, so we've taken a bunch of our concepts from how RRD thinks about metrics. So that's sending metrics into the system. Once you've sent them, you can easily explore what metrics are available. This is probably not going to be all that readable from the back, but basically you've got a region on the left side at the top, a list of apps you can choose from, and then a list of metrics for the given app, and then you can do interesting graphs. This happens, by the way, to be possibly the most important graph we've got. This is the number of movies that people start playing per second. And you can see it's a pretty normal sort of curve based on traffic and time of day, and you can do whatever you want with the system to look at that particular number. You can compare metrics on the same cluster or across different clusters or across different applications or across different regions, whatever you'd like. And you can look at high charts or RRD charts. You can create emails, blah, blah, blah. Here's where it gets kind of interesting. So, you start with the idea of being able to graph just a regular metric. This is a CPU usage on a given machine. You can see that normally it's running at around 20%, and then there's this time that it seems to go up above 80% every once in a while. You can create graph expressions that will take this from the raw metric data to conditionals. So for example, if you look at the legend here, this is CPU usage over 80%, and what you've now got actually are basically just straight lines showing the times when the CPU usage was over 80%. This is really critical because Our alerting system basically takes exactly the same graph expressions. In other words, if you can graph it, if you can visualize it, then you can alert it. And that makes it much easier for our developers to follow sort of the intuitive process of, here's this raw data, let me figure out what kind of conditions would be interesting to alert on. And once they see an interesting graph, with one click they can create an alert. With an additional enhancement to the graphing system, you can actually create an expression, for example here, that creates a rolling count of the number of times that the CPU usage was over 80%. So you can see the number here increasing, and then when you have below 80% it drops, etc. And you can create derived values based on that, like for example the at least 5 out of 10 value here, which will show you when in the last 10 minutes we've had at least 5 minutes where the CPU usage was over 80%. And again, once you've got this, you can easily turn this into an alert. And of course, you can also combine it with various different other metrics. So this is a good example of, we use a service orchestration system called Eureka. We recently open sourced it. Other people use Zookeeper for this. And this allows you to combine a CPU usage on a given instance with when the instance was actually down in our service orchestration system. Because if it's down in our service orchestration system, we don't really care that much about it. It's not actually serving traffic. It might be filling up cache, it might be doing some other maintenance. So by combining these, it makes it much easier to have alerts fire only when you want them to fire. Which, again, especially as the developers are the ones who get alerted at 2 o'clock in the morning, is something that's particularly near and dear to them. So once you've got all of this monitoring stuff and you start looking at alerting, the first thing we had to figure out is how to deal with alerting on quantities that vary on a per hour basis. Some things don't vary all that much necessarily. For example, disk usage on your machine may remain fairly constant throughout the day, and you know that if it goes above 90%, you might be looking at a problem that you want to resolve irrespective of what time of the day it is. But a lot of metrics that are based on traffic will probably look kind of like that top graph, and setting a threshold for alerting that's at the bottom of the graph is not all that useful if at 10 o'clock at night, for example, when you're supposed to be at the top of your graph, you're at the middle. So a lot of companies, a lot of people have looked at this. Holt Winters is a good example of some way to solve this that factors in seasonality. Holt Winters didn't work all that well for us for two reasons. One, it took a while to train. You needed a fairly long data set. The other problem with Holt Winters was that it was kind of expensive for us to maintain, given the number of metrics we were dealing with. We haven't talked about the number of metrics we actually monitor until now. Netflix, last I looked, which was actually this morning, we were monitoring tens of millions of metrics per minute. So basically, our system takes in tens and tens and tens of millions of metrics, logs them in every minute. And at that volume, given that we want to be able to alert on every one of them, our goal was to find a relatively lightweight way to alert on them. So it turned out that there's another algorithm, double exponential smoothing. You can look the Wikipedia article on it when you get a chance. That's actually much lighter weight and much faster to alert on. So we allow our developers to define thresholds based on either static alerting, on static thresholding, or double exponential smoothing, which by default looks at the last 10 minutes history of a given metric, predicts where the metric should be at the next minute based on those last 10 minutes, and then alerts if it's outside of those bounds. The other tool that we gave our developers was the ability to, once you've got a graph of a given metric and you've defined an alert, actually look at the historical trend for that metric and see when you would have alerted on it. That's particularly useful because we'll talk about alert tuning in a few moments, but it's typically been the case that what you do is you set up a threshold and then you wait for a while, and then one of two things happens, right? Either the alert doesn't fire when you would have liked it to fire and you go, oh, okay, well I need to change my threshold, or the alert fires when it shouldn't have fired, and then at 2 o'clock in the morning, groggily and probably pretty pissed off, you go, I really need to tune that alert tomorrow morning. Or better yet, you tune the alert right then, and because you're groggy, you get the thresholds all screwed up. So this has made it somewhat easy to tune alerts. We've actually taken some great steps beyond that. I'll talk about them in a second. I want to talk a little about a usage case for a second. So I was working on this presentation and I was looking for a graph that I could use to show this in action. This is actually the activity level on our central alert gateway. This is a little program that actually takes all of our alerts as a centralized system and then sends them to email, PagerDuty, people's phones, all of that stuff. And I was looking at the last 3 hours, and I noticed that basically around noon, it had suddenly dropped off a cliff. And I was, frankly, a little concerned by this, because this is kind of abnormal. So, the first thing I did was simply expand the time period on which I was looking at this graph. So this is about 5 days. And frankly, this didn't make me any happier, because you can see actually that we have a significant drop back at Tuesday, 11 o'clock at night, and then we have another drop Monday, 11 o'clock in the morning, and this didn't actually answer any of my questions, so let's go for 10 days. And then I noticed that actually we've had some really interesting increased alert activity over the last, let's say about 5 days out of the last 10. Which makes you kind of wonder why we're having such an increased alert activity. The good news is that in addition to the overall aggregated metric of number of alerts that go through the system, if you think about the code sample earlier, where we actually had a different metric for each application, that means that we could actually see that the application that was in purple here was having a really rough couple of days here. I actually happen to know those guys are having some interesting problems with SQS. They eventually resolved those, obviously, and this is actually a really good example of one of the things we deal with at Netflix, right? We had this application that was having a problem. Nobody else knew about it. Nobody else needed to know about it, because their issues were localized to their problem. So, of course, once I saw that there had been this CAG level issue that I didn't want to be surprised by, creating the alert on that was actually relatively simple. You can see we're applying to a cluster. This is the condition. This is a bunch of double exponential smoothing setting, and it automatically figures out who to contact in the case of a major alert. That's not all that interesting. I want to talk, however, about threshold tuning, because, well, threshold tuning is a pain. So before I do that, though, I want to talk a little about sort of the history of threshold tuning from at least my perspective. I mentioned I've been in IT for about 20 years. Back in the 90s, I saw the inroads that things like BMC and HP OpenView made into the data center as monitoring and alerting tools. And basically, where we started was the idea that your monitoring systems were owned by IT. If you wanted an alert, you would submit a ticket to IT. In my case, once or twice, I actually had to sacrifice a goat to get them to accept my tickets. And then if your alerts were not particularly well tuned, you had to submit a ticket to IT. And you're probably going to have to repeat that process a few times. It was kind of painful. So when we moved our alerting system, not just from the data center to the cloud, but also from IT to engineering, we got to a place where it was actually self-service. So the good news was you got to configure your own thresholds. And if the threshold was wrong, then you got to configure your own threshold again. And that gave you total freedom. And the only minor problem with that is that you had to configure your own thresholds. So that sped up the iteration process. That also meant you could do it by yourself, but it was still kind of painful. So we took the next step, which was to make it easy to play with historical data and see when your alert would be set off. And that made a significant difference. That definitely made our users really happy, especially when it came to things like double exponential smoothing, where there are 6 different variables you can play with to set up the condition for double exponential smoothing. And anybody who's tried to solve a 6-variable equation will probably empathize with our developers. But it still made it kind of painful, because in the end, what you're still doing is you're making the iteration process faster and you're dropping a few iterations, but you still have to do that iteration. So I work with a guy who happens to have a strong interest in control systems and statistical analysis. And he made the brilliant observation that actually computers can be pretty good at this kind of stuff. And so he decided to take about 3 weeks to write something, and what he came up with was a system that had 3 iterations. The first iteration actually went through your alerts and simply told you whether or not those alerts were correctly configured. Because it turns out that if you define hundreds of alerts on hundreds of different metrics, and then you go on your merry way developing your system and changing metric names and adding metric names and dropping metric names, in the end what you get are a whole bunch of these gray alerts which are based on metrics that no longer exist. So the good news is these alerts will never wake you up at 2 o'clock in the morning. The bad news is these alerts will never wake you up at 2 o'clock in the morning. So the first version of this just simply told you which of your alerts were valid. But he took it to the next level, and in that level, the system started being able to tell you actually what alerts it thought were correctly thresholded. So the green alerts, the system thinks are pretty well configured. The red alerts actually mean that they triggered in the last whatever time period you selected. Orange means that your alert is too tightly thresholded. In other words, the system thinks that it's probably going to fire with a bunch of false positives. And the yellows actually mean that the system thinks it's too loose, so it's probably not going to alert you when you want to. But if you think about it, if the system can do that, why can't it do this? So the system can actually now suggest different values for your alert. On the left side, and by the way, I'm guessing people on the left side will, on the far side of the room will not be able to see this very easily, but you've got basically the same graph. The big line is the line of actual value, and you can see that on the left side, the untuned alert showed only 1 interruption in the last, I think this is 24 hours. On the right side, we actually find 3 interruptions in service in the last 24 hours, and you can see actually that the little bump here is totally not noticed here. The other thing that's worth noting is the graph on the left side is the top value is 4,000, the bottom value is negative 4,000. On the right side, the top value is 2,000, and the bottom value is negative 2,000. So we've got a significantly tighter alert that still doesn't seem to give you any false alarms based on the data that we see for this given time period. So this is pretty hot. The last time I gave a presentation internally to our development group about this, I think the phrase I used was, if you don't use this to tune your alerts, you're intentionally walking around poking a stick in your eye. So actually, this is what I have about metrics, and because we actually had a few minutes and I talked to Sebastian about this, he expressed a desire for me to go into our event management system while I was up here. So I want to talk about that briefly. First of all, I want to talk a little about events versus metrics, because this can be a little confusing. Metrics typically are something that happens at a regular time period. You get your metric in once a second, once every 10 seconds, once a minute, whereas what we think of as events, which is something that happens in our environment, for example, a code push, or an instance termination, or an ASG, max, min, desired changing, happens whenever the heck it happens. The other thing is that events are point in time. So they happen basically at some point in time. They don't typically necessarily have a duration. They may indicate something that had a duration, but we think of an event as really a momentary transition between one state to another. And lastly, generally speaking, events don't have a magnitude, unlike metrics. The metrics' whole reason for existence is really to have a magnitude, because that's what they signify. An event is really more of a notice or a message. So why build an event management system? I've worked in some companies that expressed a desire for change management, and generally speaking, the people who were interested in change management were actually interested in change control. There's a big difference between change management and change control. But in a lot of these companies, what you find is that as you slow down change, you also slow down innovation, because innovation requires change. And in many of these companies, slowing down change is an explicitly good goal for us, because our whole focus, our whole belief in what makes us better and more successful is focused on speed of innovation, we can't slow down change. Our goal is to make change as fast as possible. So our change management system, which basically involved your standard file as change control ticket, fill in a bunch of fields that are irrespective of the kind of change you have, like what are you going to do, how are you going to back it up, how are you going to know that it works, who's looked over your code, and then have your manager approve it, was kind of silly. Every developer hated this, and it didn't give us any possible value. We wanted something better. The other thing is that, generally speaking, what people use change control systems for is to know what actually changed in your environment. The most intuitive, obvious question to ask at 11 o'clock at night or 2 o'clock in the morning when systems break is, okay, so who changed something? What's changed, that right before this happened? The problem is that change management systems are a poor way to answer that question, partially because they signify intention rather than action, partially because they're expensive in terms of developer resources, and also partially because, frankly, a whole lot of things happen in your environment that are probably not driven by humans making changes. Lastly, we had this issue where we kept having developers who wanted to alert on something that wasn't quite a metric. The idea was, for example, I've got a batch job, and it's supposed to run every day, and I'd love to know if it's not run in the last 4 days. And we kept making them sort of basically cast that event into a metric, which is not particularly intuitive. So it would be like, okay, so you've got a batch job. Why doesn't it keep a counter of when it last ran? And you report that counter into the metric system, and then you set up an alert if that counter ends up being longer than 4 days. And that kind of works, but it creates a cognitive load. And it creates kind of a difficult way to think about things when the really obvious question to answer, and therefore the condition to alert on, is, hey, has this thing reported in the last 4 days? So we built this system called Chronos. This is, by the way, a really good example of the great thing about working at Netflix, right? The guy who built Chronos had some other project to work on that quarter, and then he decided, no, this is more important, so he basically spent about 4 or 5 weeks in his spare time at work to build this. So it was incredibly rapidly prototyped and went into production pretty quickly, and then of course we made it better and more stable, and we're still working on that. It utilizes a system of adapters and reporters. So basically our cloud management system, for example, reports all the changes that it knows to Chronos. The tool that I have, SecurityMonkey, which notices security-related changes in Amazon, reports changes to Chronos, etc. It allows for super easy querying, either via a GUI or an API, and it allows for alarming on either something happening, which is pretty obvious, or something happening X times in Y minutes, which helps you figure out things like, for example, flapping, or, and this is the cool part, something not happening. So if you go back to that question of how do I monitor that my batch job has run in the last 4 days, it's actually really simple. If your batch job is successful, just have it send a message to Chronos that says it's completed, and then alert if you haven't seen that message in the last 4 days. That also means that you don't have to worry about all the different possible failure scenarios for your batch job that might not result in sending some sort of trigger. So this makes building dead man switch systems much, much easier, to the point where you really don't have to build a dead man switch. It's already done for you. It's a pretty medium level system, so it handles high hundreds of thousands of events per day, and it's recursive, because what happens is our alert system sends every alert to Chronos as an event. And as I noted, you can actually create an alert from your events. So our alert system and our event system actually interact. You can create an unfortunate situation where you're going to get a whole bunch of alerts, but that's freedom and responsibility for you. So what's the end result? Well, for one thing, we've seen a massive increase in change control tickets. Generally speaking, most of the development groups at this point don't use change control tickets. They just report their changes to Chronos, either by having automated systems do it or by actually reporting it manually. And we don't find that we miss it at all. Now, obviously, there's an exception. I just want to avoid anybody who's actually a Netflix customer thinking that that's how we think of the credit cards. So systems that are responsible for PCI activities or SOX activities are obviously much more rigorously handled. We do have to go through change control for that. That is documented. But we find that generally speaking, most of our systems aren't subject to SOX or PCI compliance regulations, and that makes it much easier to handle those systems. We also have much better visibility into changes. So it turns out that this has caused a huge difference in the last quarter in how quickly we've been able to figure out what's actually caused an issue in production, especially when it comes to bad code deployments. Not that we ever have those. So it used to be, because again, we're a very decentralized environment, development groups don't have to tell anybody that they're actually developing code, that somebody would push code, something would break, and the first question we'd have to ask is, again, what broke and who might have caused this, and that could take 30, 40 minutes. We now see typical rollbacks happening within 5 to 10 minutes. It's super, super wonderful. And I've got to tell you, I'm not a big guy for prescriptions, right? We're all smart people and we all do what makes sense to us. This is one of those times where I really just want to say you should do this. I mean, however you do this, whether you build your own system, and again, this was 4 or 5 weeks of part-time work, it's Python, it's relatively lightweight, or you do something on top of some sort of centralized log management system, having easy visibility into the events that happen in your system is really, really important. And making it so that visibility is not driven by making people have to jump through hoops or have to remember to do something, or are driven by some sort of process that you have to make people comply with, is really, really helpful. Both to give you the visibility that you need, to give you as much of the information that you need to run your systems, but also to free your people up from stupid process. We're not big believers in stupid process at Netflix. So, there are a whole bunch of things I didn't talk about. I didn't talk about end-to-end testing and alerting. So the idea of looking at business transactions as they go through our 400 plus applications in our environment and figuring out when those business transactions go wrong. I didn't talk about how we monitor our system from the outside of the cloud. I didn't talk about the interesting challenges around managing our new CDN service, OpenConnect, which is very much designed not like a cloud instance, because we're talking about a relatively small number of physical boxes deployed in ISPs. And I didn't talk about jobs, of which we have many. And I'm on the lookout for a whole bunch of more smart coworkers. That's it for me. Any questions?
So you'd mentioned using double exponential smoothing as kind of an automatic way to find thresholds for a lot of metrics and create alerts off of that. And I was wondering if you have any similar methods for, say, metrics that are measured daily or weekly.
Well, yes, actually we do. So double exponential smoothing was our first serious foray into adaptive thresholding, and it's worked relatively well for us. We're actually in the middle of a migration from our old monitoring system to a next generation monitoring system, which actually allows you to not just graph but then also alert based on averages or other operations on historical data. So for example, this system will let you define an alert based on whether a given minute's value for a threshold is more than, let's say, 10% different from the average of the last 4 weeks or the max of the last 4 weeks, etc. And we think that works reasonably well for us. It's still in testing, but so far it has promise.
So I like the graph there that you showed how you optimized your event alerting by deciding whether you were actually hitting thresholds or not. But you didn't actually say what the method was that was used to do that, other than it had to do something with control systems. Is that someplace published?
You're talking about our alert tuning system? Yeah, so it's not published yet. I will say this. We're big believers in open source. And we're in the fortunate position, unlike Google, that many of our technologies are actually much more standalone and modular. So our goal is to open source everything. So while it's not published yet and it's not been open sourced, my expectation would be that at some point it will be, as quickly as we can get to it, while actually still working on internal projects. The first thing we'll need to do, of course, is open source our basic monitoring and telemetry system, and after that, open sourcing the alert tuning stuff and the other sort of magical things that it does would be fantastic. And I know the guy who works on it would be very enthusiastic about that.
So sorry, I think it's very interesting all the methodology to go to reduce the errors, but I think that you cannot get a zero error on the alerts, which means basically you will have to evaluate the cost of your errors, in the sense that as a business it may be more costly reducing the amount of alerts that you're getting as opposed to have wrong alerts. Is that being tied up into the decision process?
So if I understand your question correctly, it starts with an assertion that you can't completely eliminate, let's say, either false negatives or false positive in your alert system, and that there's a cost to both false positive and false negative systems, and it's a question about how we actually factor that cost in. Is that right?
Correct.
Okay, good. And you asked if, as a business, we think about that.
Well, I mean, like we've seen you showing us how to get to zero, to decrease the amount of alerts or to optimize them, and you may, as a business, you may not want to do that because you may ignore the errors that are more costly by doing that.
Yeah. So again, you have to remember that. Let's go back to that complete responsibility model, right? You own your service, so you own the alerts on that service, and you own actually keeping that service available, which means that every developer who's responsible for a given service and every development group that's responsible for a given service has to make those decisions for itself. In our decentralized environment, there's no management edict about how you should handle alerting. So every development group figures out where the right balance is for it. Some groups may opt to tweak the knob to potentially having some false positives because they don't want to have false negatives. Some groups may opt to tweak the knob toward more false negatives because they're willing to accept that cost, especially if they've engineered their service and the service dependencies by their downstreams. So if their service is having availability issues, it doesn't actually affect them. So we've made those decisions happen as close as possible to where the service is actually managed. So it's not in the hands of some alerting people or some monitoring people or the NOC. So you are responsible for how your alert fires, and you're responsible for making that sane. So, I'll give you one possible reason why that's a good thing. Back in the days before we moved away from the data center, I remember I was working with the NOC because I was on the systems engineering side, and they mentioned, yeah, the API service, they have alerts that fire hundreds of alerts at us every evening, starting at around 6 o'clock. And the API guys have said, yes, that sucks. And we'll definitely get to tuning those together with the monitoring people because they couldn't tune it themselves soon. But right now we're working on some feature releases. So the NOC just had to sit there and take it for day after day after day. Now, since you own the availability and you own getting the alerts, you get to figure out what the right balance is. Does that answer your question?
Yeah, that's great. Thank you.
Good.
I would like to ask how your in-house system compares to some available open source or commercial alternatives, if you can give us this kind of frame of reference. It seems to be very advanced, so I'm not sure if there is anything equivalent to it, but like closest alternatives.
It's a good question. We started working on this system. So actually, funny little history lesson. This system started out being the brainchild of a systems engineer who looked at a bunch of other systems that were available in the market back in, I want to say 2008, and didn't like any of that and said, hey, I'm going to write something. And it turned out that what he wrote, this was again one of those part-time projects, ended up being hugely, hugely favored by the developers. So fast forward 4 years later, and what you've got is about 3 people working on this full-time. 3 people working on your monitoring system full-time is kind of expensive, right? And we've certainly gotten our money out of this, right? This system kicks butt. But it's easier to amortize that over a 4 billion plus a year service with, you know, hundreds of developers. So one of the things I've wondered about, and I've talked to other sort of smaller startups, is how do you do this if you're a smaller company? Obviously, once we open source this, one of the possible outcomes is, you know, hey, use this. But I will also tell you, I think if you look at what I presented here, not so much as this is the system you should have, but rather as the design principles for the system you should have. You can find open source systems that will give you much of this functionality. And I'll tell you, as somebody who does development and as somebody who cares deeply about monitoring and alerting, my official title, I think last time I checked, was Senior DevOps Engineer, Monitoring. If you create a system out of an amalgamation of open source components like Ganglia, like Nagios, like whatever you want to use, right, that makes it easy for your developers to send in whatever metrics they want, and easy for your developers to set up alerting. And then you use whatever service you want to actually get that alerting to the right place. And by the way, this is one of those things where we chose to use a SaaS, PagerDuty.com. Anybody here use PagerDuty?
Yeah, we use it.
They rock. So I think you can come up with a collection of open source tools that will give you much of what we have without making the significant investment in creating your own personal system. And then, of course, you know, again, we'll open source this soon, and then you could just use it. Did that answer your question?
Yeah, thank you.
Good.
So I had a question about the false positive and false negative detection. You said this was automated. I'm wondering what kind of techniques you use to, in an automated fashion, determine if something's a false positive or negative.
Well, it's a good question. It gets into a whole bunch of mathematical analysis that I am only somewhat capable of understanding myself and probably will butcher if I try to explain it. But generally speaking, you know, imagine a metric that ranges between, let's say, 10 and 15 all the time. In other words, you can look at a given history, and you've got, and typically for our metrics, we have them on a per minute basis. So for a given week, you'll have whatever 168 times 60 is, you'll have a whole bunch of samples, right? And if all of them are between 10 and 15, for example, then any alert that fires at below 15 can intuitively be thought of as having a bunch of false positives. Does that make sense so far? I'll take your silence as a yes. So in that case, if you see that there's a certain condition that gets alerted on a whole bunch, you can make some reasonable guesses that it's a false positive. Similarly, if you see that in a given time period, your threshold is set so high that your system never even reaches within, let's say, 25% of it, you can make some guesses that maybe that threshold is too high. Now, our alert tuning system is actually more of an alert advisor, so it's not actually going to change your alerts for you. That would be interesting and hilarious. But it will basically point out these kind of situations and offer you an opportunity to use different thresholds that might be more sane. It's up to you, because you're the owner of the system, to know whether or not those metrics actually make sense and those new suggested thresholds make sense. Did that answer your question without getting too technical?
Yes, thank you.
Awesome. Other questions? Fantastic. Good. Well, I'll be around for, at least lunch, and I'll be hanging around a little after that. So if you have any questions or you want to talk about anything in the Netflix environment, I'd love to chat. Thanks so much.